Hi, as discussed in our lecture, I am giving you the video for proof of root 3 and root 5 are not irrational numbers. First we will take root 3. We have to prove that root 3 is an irrational number. We use indirect method to prove this. So let us assume that root 3 is a rational number indirectly. So root 3 is equal to P upon Q. It can be expressed as P upon Q, where P and Q are integers. Q is not equal to 0. P and Q have no common factors except 1. Now what we do? Squaring both sides. Squaring both sides. 3 is equal to P square upon Q square. We square both sides. So root 3 square is 3 P square upon Q square. We take Q square this side. So we get 3 Q square is equal to P square. So therefore P square is a multiple of 3. Because P square is equal to 3Q square. So P square is a multiple of 3, right? Because it is equal to 3 into something. If P square is a multiple of 3, then P is a multiple of 3. Okay? If you have anything, a square is multiple of 3, then the number is also a multiple of 3. For example, 9. 9 is a multiple of 3. 27. 27 is 3 into 9. So again 27 is a multiple of 3. So anything square multiplied by 3 is a multiple of 3. So the number is also the multiple of 3. Correct? Oh no. P square is a multiple of 3. If P square is a multiple of 3, then P is also a multiple of 3. So therefore P is also a multiple of 3. So P is also a multiple of 3. Okay. Now that means so we can write, or if P is a multiple of 3, then we can write as P is equal to 3 into T. If P is also a multiple of 3, we can write P is equal to 3 into T. Now squaring both sides, we get P square is equal to 9T square. Squaring both sides. Squaring both sides, we get P square is equal to 9T square. Now here we have 3Q square is equal to P square, and here we have P square is equal to 9T square. So P square, P square. So ultimately 3Q square is equal to 9T square. We get 3Q square is equal to 9T square. So from both these expressions we get, therefore 3Q square is equal to 9T square, or Q square is equal to 3T square divided by 3. So again, if Q square is equal to 3T square, Q square is a multiple of 3, right? Multiple of 3, because it is equal to 3 into some number. So therefore Q also is a multiple of 3. Then Q is also a multiple of 3. Correct? Thus P and Q have a common factor P and Q both have a common factor, both have 3 as a common factor, right? Thus P and Q both have 3 as a common factor, but this contradicts our statement that P and Q do not have a common factor, correct? But this contradicts our statement that P and Q do not have common factor except one, right? So therefore our assumption that root 3 is a rational number is wrong. Hence root 3 is an irrational number. Okay, this is how we prove that root 3 is an irrational number. Now, for root 5 as a rational number, what we do? Similar things. We do the similar things. So, in the second part, what we do? Root 5. Root 5. So the similar steps, I am just giving you the main things. What we do? Let root 5 is equal to P upon Q. So we get 5 is equal to P square upon Q square. So 5Q square is equal to P square. From here we get P is a multiple of 5 because P square is a multiple of 5. Okay. Now, so therefore we can write P is equal to 5m. So P square is equal to squaring both sides 25m square. Same steps, but P square is 25m square. So from this 2 we get 5Q square is equal to 25m square. So Q square is equal to 5m square. So again Q is a multiple of 5. So from this and this we can say that 5 is a common multiple of P and Q, which contradicts our assumption that P upon Q is a rational number where P and Q have no common factor except 1. So our assumption is wrong. Correct? So this is how you can prove that root 5 is a irrational number.